Baik, Assalamualaikum warahmatullahi wabarakatuh. Soal ujian akhir semester untuk mata kuliah statika struktur nomor 2 ya, kita akan coba menjawab. Mudah-mudahan nanti para mahasiswa yang kemarin itu sudah mengerjakan ini bisa menjadi koreksi, dan untuk ya bonus ya ini dapat disalin kembali, dan saya akan tambahkan sedikit variasi dari pembebanannya dan kalian coba kerjakan di rumah. Baik, problem seperti ini mungkin kita bacakan ya problemnya. Beam AB, ini beam AB is connected to the wall using bolt A and B. Jadi di sini dipasangkan ke dinding menggunakan baut A dan B. Using plate fixed at the end of A of the beam. The beam is subjected to a triangular distributed load as shown in figure 1. Beam ini dikenai beban segitiga. Beban segitiga ini 2000 Newton per meter. Uh, ini tidak ditulis di sini. In addition to axial load 1000 Newton. Jadi di sini juga ada axial load. Axial load ini besarnya 1000 Newton. So the beam is subjected to axial loading, and then triangular distributed loading as shown here. And the dimension of the beam, the length of the beam 4 meters, so AC 2 meter and BC 2 meters. What else? Yes, that's it. And then draw the free body diagram of the figure 1. We have to draw the free body diagram showing all the forces acting on the beam. Not only forces disturbance, but also the reaction due to the loading. Okay, and then calculate internal loading at C. So internal loading at here, due to the loading as shown in figure 1, it is important to note that the beam is also subjected to axial loading at B. So the internal loading here at C, in order to know the internal loading at C, we have to consider one is the triangular distributed load that acting right here, and then axial loading about 1000 Newton at the end of the beam at B. Okay? So in this case, you have to consider the segment BC here, and then calculate the intensity of the triangular distributed load at C. Well, then use the equilibrium equation, gunakan persamaan kesetimbangan to calculate this. What is the normal load or force at sea? And what is the shear force at sea and the moment that acting at sea? So that's the problems, very clear. Now we try to solve. We start with free body diagram. Kita mulai dengan FBD. Ya, untuk FBD kita gambar aja. Just draw the triangle here, in which this part maximum of 2000 Newton per meter, but is triangularly distributed across the beam, so it's not like so what I want to say, the load decreases up to zero at the end of beam at B. So this we call it triangular distributed loading. So we have to pay our attention. So this one A, this one C, and this one B. So we have to pay our attention on C right here. So first of all, we have to know what is the loading at C. Okay, say WC. So how to calculate this? To calculate this, we have to consider one big triangular right here. Say ABC. This one is D. Okay. So we have to consider triangle ABD and another triangle, small triangle right here. CBCE here. CBE. CBE. So let's do it. Let's do it. So right here, 2000, wait a second, 2000, 2000, right? So 2000 divided by WC here is equal to AB is 4 and CB is 2. So, I made mistake here. It's supposed to be 2000. Okay. So, 4WC equal to 2 by 2000, or equal to 2000 over 2. This is 1000. 1000 Newton per meter. So right now we know that this one is, oh, I made mistake. Okay, 1000. Okay, this is 1000 Newton per, or 1 Newton 1 Newton per meter, right here. Well, now let's see. So we have here 1,000, and this one is supposed to be 2 meters, right? 2 meters. And then what is the concentrated load at this portion? I mean, at CBE, triangle CBE. Concentrated load at the center of gravity right here is 1/2 by 2K, 1/2 by 2, and then multiply by 1,000 right here. So this one is 1,000. Let me correct it. Okay. So how much is this one? 2,000 over 2. It's 1,000, right? Yeah, 1,000 Newton because it's concentrated load. Concentrated load. Well, in addition to 1,000 Newton concentrated load due to triangular loading, we also have axial loading 1,000 Newton at B. Now, when we apply the equation of uh, equilibrium, when we apply the equation of equilibrium at the x direction, so sigma fx, we know that this sign is supposed to be positive to the right equal to 0. Then what we'll see, 1,000 Newton is plus right here. And then NC, we assume that at the beginning, we assume that the direction is to the left, so it's negative here. Then NC is equal to plus 1 kilonewton or 1,000 Newton. It means that we have to correct here. The direction is correct, okay? Jadi tidak berlawanan arah. Ini sudah betul seperti asumsi kita. Okay. Now let's check on the vertical direction. On a vertical direction in which plus is to x, to y positive plus right here. So sigma Fy equal to 0. Right here we have, so when we cut this one, we have PZ, yeah, here, P VC, right? So VC, because to the plus y direction is plus right here. And then due to the triangular concentrated load, the negative direction of y. So, okay, let me correct this one also. This is supposed to be 1,000, right? So VZ equal, so VZ equal 1,000 Newton. Okay, and then let's check what is the moment the at point C. For the moment, counterclockwise supposed to be plus and clockwise minus. So right here we know that we assume that this is the MC. This one MC, right? So it's negative, okay, negative. And due to 1,000, due to 1,000 right here, sorry, we have to correct this one. This one is supposed to be 1,000, okay, 1,000. This 1,000 Newton from here to here, the lever arm of the load 1,000 is 2/3 of the CB. Okay, then we have here 1,000 and 2 by 3 equal to 0. Then MC is supposed to be clockwise, so plus or negative. Yes, it's negative right here. And then 1,000 is supposed to be like this. This is also negative, clockwise. Clockwise, so 1,000 minus 1,000 by 2/3 equal to 0, then MC equal to minus 1,000, 2,000 over 3. So this, let's correct this again. Okay. So 2,000 over 3 Newton meter. Ini berlawanan arah ya. So the one that we denote, we assume that the moment acting at C, initially we assume in clockwise direction, but actually we obtain negative. It means the moment that acting right here is vice versa. So that's the answer of the problem, okay? So we got MC, we got the Fizzy, and we got NC. So we answer the problem, all the problem. We answer all the problem. So student, please um, review this this solution, and then I will ask you. This is for you to have additional grade from me. Okay. Uh, let's assume if we have additional, if please calculate, okay, if we have additional concentrated load, so 1,000 Newton. Okay, please pay attention, perhatikan baik-baik. 1.000 Newton ini bekerja pada C, itu sebagai beban terpusat. Tetapi dia sebenarnya juga dikenai beban triangular load yang ada di sini. Jadi coba dikerjakan lagi. Ini disalin lagi dengan baik. Setelah itu kerjakan yang saya minta ini. Jadi selain beban segitiga, selain beban aksial, juga ada beban terkonsentrasi sebesar 1.000 Newton atau sekitar 100 kilogram. Ya, sayang sekali para mahasiswa semua tidak hati-hati sehingga banyak yang salah ya jawabannya. Jadi coba dikerjakan kembali. Oke. Jadi kalau di sini ada angka yang salah, coba dicek kembali seperti saya tadi sudah koreksi bahwa bukan 1.200 tapi 2.000. 1.200 itu soal ya, jadi saya robah menjadi 2.000. Sekian saja, mudah-mudahan bermanfaat untuk kalian semua. Masa libur barangkali hati-hati, sehat-sehat semuanya, dan kita kembali lagi nanti bulan berapa ya kuliah lagi, masih lama. Sementara nilai harus masuk tanggal 30, jadi segera kerjakan ini. Oke, terima kasih. Bye-bye. Assalamualaikum. Mati.